Here we have problem number 4. 200 kilogram weight is hanging from the ceiling by a thin copper wire in its fundamental mode. This wire vibrates at frequency 429 Hz. You then increase the temperature of the wire by 29 degrees Celsius. By how much will the fundamental frequency change? Find the magnitude. Okay, so basically we have a thin wire that is made from the copper. Okay, now when you increase the temperature, when you increase the temperature of the wire, what will happen? The length will increase, okay, and thus the mu will be changed. When mu is changed, then the frequency also will be changed. Okay, so first of all, let's find change of the wire. So we know the formula where final length is equal initial length inside the bracket 1 plus alpha delta t. Okay, then we can say that length of the final divided by length of the initial 1 plus alpha delta t. So alpha is given, coefficient of linear expansion is given, delta t is also given, which is change in temperature is 29 degrees. Okay, so you plug it and you can find that L initial L final divided by L initial will be equal to this value. So let's keep it as it is right now. Then what we have a formula where any fundamental any frequency is equal V times N divided by 2L. Okay, and V is equal to the T over mu, and then mu is equal M over L, so you got this one. And then if you want to find fundamental frequency, what you have to do is basically you have to put 1 into N. So you put 1 into N, and then you get fundamental frequency will be equal to the 1 over 2 square root T over ML. Then after that, what you have to do, you have to square both sides. Okay, you square both sides, and then L will cancel, and then tension itself is equal to the mg, okay, which is mg. So m will cancel, L with 1L will cancel. At the end, you will get that frequency squared will be equal 1 over 4 GL. Okay, so this means that the fundamental frequency is inverse proportional to the 1 over L. Okay, so all frequency fundamental squared is proportional to the 1 over L. So if that's the case, then we can just make a ratio. We can just divide them. So frequency final squared divided by frequency initial squared is equal, so this one is equal 1 over L final divided 1 over L initial. Then you do it, then you will get L initial, L final, which is equal to that one. And then we know that L final divided by L initial is equal to that one. Then from there, you can calculate what is the V final here. Okay, V final will be equal to the V initial squared here under the square root L initial divided by L final. L final divided by L initial is equal to that one, so you have to inverse it. 1 over 0.00493. You square the initial frequency, and then you will get that final frequency is equal to the 428 Hz when you increase the temperature. Then you just have to find change in frequency, where initial frequency minus V final frequency, or you can just put a model here so that you can get only positive number. And you do calculate it, and when you calculate it, you got that the difference of the frequency will be 0.1057 Hz.